Good afternoon, morning, whatever time of day it is for you. Welcome to the lesson 9.3. I'll adjust this so you guys can see me a little bit better because it's important that you can see me. The big deal of today is talking about how things are transformed. We're looking at our quadratic equations and the way that they are transformed. They're graphs. The transformation that takes place is going to be either moving the graph, shifting it all the way to one side, left side, right side, shifting it up, shifting it down, making it stretched or compressed. And we'll be using those types of words to help describe the transformations that take place. So one of the transformations is a translation. Remember, translations are things that take the entire shape and just shift it left, right, up, or down. So if you look at the example that I have on our notes here, is the black graph with the equation of f of x is equal to x squared. That's my parent function. The x squared plus 6 shifts up 6 spots, and the x squared minus 7 shifts down 7 spots from the parent graph. So we're always going to be talking about how these graphs shift or how they translate in relationship to the parent graph. So we're going to be using words again like up, down, left, right, compressed, and stretched to describe the types of transformations that are taking place. So you could make a quick sketch saying that these things go up 6 spots and this one goes down 7. All right, so let's get an example for us. We're supposed to explain how the graph compares to the parent graph of f of x. So in part A, h of x is equal to a 10 plus h squared. Now if you were to write that in the same order here, we would have an h squared plus 10. And that should give you a little bit of an idea as to how this is going to translate, because we have this plus 10 like we did on the previous page. That means that our graph is going to translate up 10 spots. And on the next one down, we're going to have a translation of down 8 spots because of this negative 8. So we're looking at the numbers carefully, and that's just in comparison to the parent graph. So it's just moving down 8 spots. Now here's your multiple choice question that you'll be filling out on the Google form. It looks kind of sweet. The dilations will be the next thing we talk about. A dilation is where we're going to use these words that we're going to stretch or we're going to compress. So in our examples, we're going to make the h of x where we have 1/2 of x squared. Since the number is less than 1, it's going to make it wider. Or we're going to stretch it. You can imagine like taking the graph from the parent graph and pulling it wider. We're stretching it. So we're going to describe this as it's being stretched by 1/2. On the other one, we're being compressed. So if the number is greater than 1, the coefficient of the x squared, if it's greater than 1, it's being compressed by a factor of 3. So times 3. So it's 3 times pushed in. Okay? Now our next example talks about reflections. Now reflections are again where we have the U shape, we just flip it right down, or if it's a U shape and we flip it up. So a reflection happens if my A value is going to be negative. So it's going to be opening upward if it's a positive A, and it's going to be opening downward if it's a negative A. So we will use words like flip if our graph is being flipped, or you can always use the reflected across the x-axis. That would be probably a better mathematical term. Our last type of transformation we have is the horizontal translations. Now translations of the horizontal kind happen when we have a plus or a minus h in the squared stuff. So if h is greater than 0, the graph is translated to the right. If h is less than 0, the graph is translated to the left. So in example 2 here, it says how we're supposed to describe how the graph is being translated or how it differs from the parent graph. So We don't have a horizontal translation, but you will in your assignment. It's important for us to understand that we have a factor. It's being compressed by a factor of 3. So you're going to use those words. Compressed by a factor of 3. It's flipped or reflected across the x-axis because it's negative. And we have a translation of up 1. So it's translated up 1. So those are the 3 things that are happening to this graph from our parent graph. Now in your assignment you'll have to graph both items and then be able to describe the translations that are taking place or the transformations that are taking place. Here's your last example that you have to do on the Google form. And then folks, that's all we have for you tonight on this video, or this morning, whatever time you're actually watching it. And good luck to you. This is Bermanation signing off.